Hello. In this video, I'm going to briefly explain how we go about computing a histogram, which is something that you have most probably seen before elsewhere. A histogram gives us an estimate of the probability mass function for a random variable, and it can be computed by repeatedly sampling the random variable. By the end of this video, you should be able to calculate approximate probability mass functions by constructing a histogram. I'm going to test that you understand how this procedure operates by giving you a small computer programming exercise to perform, however. By the end of this video and that exercise, you should be able to compute these histograms relatively easily. To give you some context, we have seen how we can calculate the expectation of a random variable by repeatedly sampling the random variable and by calculating the sample mean. The process of calculating a histogram operates using a similar logic. Now, however, we must calculate a vector of sample means rather than calculating a single number. Without further ado then, let's get on to the content of this video. We have introduced the probability mass function in previous weeks using the example illustrated here. We have 6 individuals and we select one of them randomly. Each of the individuals has a numerical label, so if we select Stephen, our random variable is 1. If we select Conrad, our random variable is 2. If we select Michael, our random variable is 3. If we select Carlos, our random variable is 4. If we select Maeve, our random variable is 5. And if we select Dawn, our random variable is 6. In addition, there is a probability for selecting each of the people in the experiment. The probability of selecting Stephen is P1. The probability of selecting Conrad is P2. The probability of selecting Michael is P3, the probability of selecting Carlos is P4, the probability of selecting Maeve is P5, the probability of selecting Dawn is P6. These 6 probabilities can be grouped together in a single function called the probability mass function. When this function is evaluated for a particular small x values, it gives us the probability that the random variable X is equal to small x. For example, if small x is equal to 2, the probability mass function is equal to P2, the probability of selecting Carlos. Let's now move on to this business of calculating a histogram and how this works. To illustrate what we do when we compute a histogram, consider the image shown on this slide. The red and blue boxes on this slide indicate the outcome when we roll 2 dice. The green box then shows the sum of these 2 numbers, which is the random variable for which we are going to estimate the probability mass function by computing a histogram. We have, in fact, drawn a histogram for the experiments that we have performed in the image on the slide, as we have drawn a single bar with a height of 1 to indicate that the single experiment that we have performed thus far gave us a value of 5. We can now repeat this experiment. In the second experiment, we rolled a 9, so we now draw 2 bars, each of which has a height of 0.5. These 2 bars indicate that half of the experiments we performed gave a result of 5, and half of the experiments we performed gave a result of 9. Furthermore, you can see that even as I've said this, the video has continued, and the bars have been constantly updated to reflect the new results that have been obtained in each of the experiments. In particular, each time we get a new result, we increase the height of the corresponding bar. When we compute a histogram, we are thus simply counting the number of times each of the possible results that we could have obtained for the experiment have appeared. In other words, and for those of you who are really on the ball, what we do when we compute a histogram, we are sampling from a multinomial distribution. Hopefully, this video was pretty clear, and you now understand how we can calculate an approximate probability mass function by computing a histogram. As I said at the start, the programming exercise are going to help to reinforce your understanding of this concept. What we are essentially doing, however, is sampling a random variable multiple times and counting how frequently each of the possibilities in the sample space occur. Thanks for your attention.